So in 3.3, we need to start out and we're going to take a look at data that comes from a data set that has two variables, okay? So let's look at the example we have here below. This was where we ended up last time, but we didn't quite plot this data. So this is the year of an election in the United States, national election. This is the Electoral College margin of victory for that year. Now, what we've typically been doing, we've been typically entering one data set, like the speed of the cars, grades that you made, sizes of class. Now we've got two variables in our data set. So we need to be able to enter this, and I'll just go to my calculator, and I've got if you're not there, it's a new, what kind of document? To enter the data, list and spreadsheet, okay? So I'm gonna go ahead and enter this in. I've got the year, and I've got the Electoral College margin of victory. So I'm gonna enter that data in. You can follow along. So I'm just gonna put the election year, it has to be one word, and Electoral College, there we go. So we're starting with the 1984 election, which was the first time that yours truly voted. And then we'll move on. 1992, 1996. Okay. So those are all the years, and now we'll do the margin of victory. And I'll just double check all of that. 512, 315, 202, 220, 535, 192, 126, and we're good to go. Okay, so all of the data is in here, and now I want to plot this particular data set. So to plot this control data, where do you think I go next? I've already done that. Yeah, data and statistics, okay? Now, I've got two variable data, so here's an x-axis and here's a y-axis. So on the x-axis, I'm going to put my year, okay? And then I think you can tab or you can move you might even see this. Let me see if someone got it up on their screen. You're entering the data. Yeah, so if you come over here, so you've got you already got yours, okay? Did you tab or did you just move the mouse over? Yeah. So you should be able to move the mouse over here to the y-axis, and we're plotting the Electoral College. Okay, now we see this is different. This is called a scatter plot. Okay, so I've got two variables. On the x-axis is the year of the election. On the y-axis is the margin of victory that you see here. Now, what are the kinds of questions I could ask myself about variables that are a data set that has two variables? If it's one variable, like your shoe size, I'm doing like the median, the average, the mode, those kind of things. But if I start to talk about shoe size and your IQ, what kind of question, what am I interested in? If I talk about shoe size and IQ, what's the next logical question if I have data that shows that? Is there a relationship, that's what I'm saying. So what is it? I've got years and I've got the margin of victory. What's the question I want to be asking myself? Yeah, so the moment I have more than one variable in my data set, I'm interested in the relationship between the two. Slade, how's this book working out for you? Why don't we turn to page 331? Okay. Guys, so the minute I have two variables in my data set, I'm interested in the relationship between the two. So if I'm looking at the margin of victory in the Electoral College, where does it start out in 1984? What's the margin of victory in 84? 512. Do you know how many Electoral College votes there are? Any of you take social studies, government, anything? They're 538. So someone had a 512 margin. That's That's Ronald Reagan in '84. I don't think we'll ever see that again, a 512 margin of victory. But then what happens as time goes on? What's happening to the margin of victory? It goes down. The closest we ever had was in 2000. The margin of victory was 5 electoral college votes, and then it appears to go up. But what's the latest trend in the last 3 elections? Yeah, it's getting closer. It's getting tighter. Okay, so the obvious question is, am I seeing something from the data? Am I seeing a trend? So that's what I'm trying to ask myself, and I can look at that with 2 variable data. Now, when you're in this data set, you can do menu, analyze, regression, and every time we pick this, it's going to be linear mx plus b. So you see what I did there? So it's menu, analyze, regression, and right now I could hide it, but then I'll do it again. So menu, analyze, regression, show mx plus b. And, oh, sorry if I did that. Let me try it again. I think I actually moved data points. I want to get rid of that. Let me do that again. Control, got several things going on. Control document, add data and statistics. Let's do election year. Let's do electoral college. Menu, analyze, regression, show linear. What I'm trying to do is to move this function here. There we go. Okay. What did I just do? I'm going to leave it right there. Okay. So what I'm doing is I'm trying to model this data set. So I'm saying that this line is an approximation, it's a model of the data set. Now, is this a good model for the data set? Is this line a good model? What do you think? What makes you say it's a good model? It's in the middle, okay. But what I'm trying to figure out is like, okay, if I look at this line, okay, this line, it does a pretty good job for these 2 data points, but this model overestimates these data points here, and it underestimates here. Yes? Yeah, so it's trying to say, like, can I fit this data set with a line? Okay, yes, I can. There's the line. This is called the line of best fit. So this is the line that best fits this data set. And by best fit, it means the distance from the line of each of these points is kept to a minimum. So this is the best line that there is, okay? Now, the other question is a line a good way to model this data set? So that's the other question we got to figure out. Because if you look at what's happening here, guys, there's a lot of conversation I'm competing with, okay? I need you guys to control that, please. This data set, it looks like it was trending down and then it went up and then down, so maybe a line is not the best model. That's a different question. But if there is a line that best fits this data set, this is it, okay? So it's what, negative 10.4667 plus 21,211,204 is the line there. So I've got a line of best fit, and let's just look at that. So I've created that line, and you see that line here. So if I look at this, what is the line that we have? And there's what you see there. So negative y equal negative 10.6833x plus 21. What did you guys get on yours? The number that's out. So plus 21, what? Is it what? Is it the same thing that I got here? Oh, sorry. 2120.4. Okay. Pardon me? You got this? Okay, let's look back at our data set and let's just confirm. If I look at my data set, did I write one wrong? Which one? 84, 88. Okay, hold on. We've got the correlation coefficient that tells us whether or not this is a good model. Okay, so correlation is a number between -1 and 1. Okay, if it's 1, it's a very strong positive correlation. If the number is -1, it's a very strong negative correlation. Okay, so what do I mean by positive and negative correlation? Positive means if the numbers on the x-axis are going up, the y-axis are going up. Negative means if the numbers are going up on the x, they're going down on the y-axis. Okay, so somewhere in between. So there's a coefficient of correlation we're going to calculate. The closer that is to 1 or -1, the stronger the correlation is going to be. So that tells me whether or not linear was a good fit for this model. So to find the correlation coefficient, so on my calculator, I'll just create a new calculator page, and I can just go menu, statistics, and these are stat calculations, linear regression, mx plus b. Every time we do it, it's always mx plus b, not a plus bx. So what were my x values in this chart? The year. What were my y values? Electoral college. So I do that, and that comes back and tells me, here was this line, mx plus b. M was -10, that's my slope. Y-intercept, we just found that a moment ago. And then R, this is my correlation coefficient. So my correlation coefficient is -0.7336. Okay, so the correlation coefficient here is -0.73, and it's a little bit, 733 is what I found in that particular one. So in this case, I found for the one that I just did was -0.73, what was it, 36? Is that what I said? -0.7336. So correlation is a number between what? -1 and 1. Okay, the closer it is to 1 or -1, the stronger the correlation is. So this is -0.73. So this is a negative correlation. Is it a really, really strong one? Not really. So it's okay. It's moderate. Okay. So it tells me that it makes okay sense to look at a line between the data set, but it's not great. So let's look at an example of what correlation would look like in other data sets. This is what a correlation of 1 would look like. Okay. So that data can really be modeled well by a line. Okay. And if you think about it, the numbers that are negative, when does slope look positive or negative? Yeah, so this looks like positive slope, this looks like negative slope. That's how I remember correlation. So this is a positive correlation, very close to 1. Okay, this is much worse than the data we just looked at a moment ago. You can see when I draw a line through that, that doesn't look like the line really models the data set very well. So this is about a -0.5 correlation. Okay, so ours was a little bit stronger than that. If you look down here, this is a positive correlation, and it says 0.85. So you can see this is probably a better data set than what we saw here. Okay, the data is a little bit tighter to the line than what you see here, so that's why this number 0.85 is closer to 1. Here you see a correlation of 0.5, positive 0.5. Okay, that's, I mean, if you think about it, when you get to this, is the line doing you a good job of modeling the data set? In this case, no. I mean, this line just doesn't really tell the whole story of what's going on. So you want numbers that are closer to 1 or -1 for your correlation. And so, like I said, think of it like you do with slope being positive and negative. Okay. So what we want to do now, let's move into a different data set. So we're going to take this data set, we'll enter it, we'll find the correlation, we'll find a linear model, and we'll answer some questions about it. So let's look at this particular data set. Following data says 10th graders in the USA who have reported drinking alcohol in the last 30 days. Okay, this is a no judgment zone, so we're just going to look at the data set. Nothing else comes out here, so let's just look at this and take the data set and see what we can figure out with the data set. So I'm going to create this data set and put it into my calculator. So you should be able to follow along. This would be a sort of a good example of something that might show up on a test, being able to enter a data set like this. So I'm just going to go ahead and create a new document, get rid of the ones that I have. So I'm going to create a list and spreadsheet. So I've got the year, and I'm just going to put alcohol. And so let's just enter the years. The years start at 2000. So 2000, 2001, 2002, 2003, 2004. So all the years from 2000 to 2016 should be entered here. And then percentage who've reported alcohol uses is 41, 39, 35, 35, 35. In 2005, it's 33, 34, 33, 30, 29, 29, 27, 28, 26, 24, 22, 20. Okay, I'm going to double check these numbers. That's the most important thing before you do any calculation. So I start out in 2000 with 41, 39, 35, 35, 35, 33, 34, 33, 30, 29, 29, 27, 28, 26, 24, 22, and 20. Okay. Now, do you get a sense for what's happening in the data set so far? Anyone? What's happening over time? What do you think is happening? Yes. It feels like the numbers are going down. I mean, you typed them in, right? Question, Spencer? Okay, so it feels like the numbers are going down. Okay, so control document. Okay, before I do anything, I'm going to create a new data and statistics. Okay, to get to my line of best fit, first I have to get to the scatter plot. What's going on the x-axis here? The years. Okay, what you typically want on the bottom axis is the variable that you're really not doing anything. I don't have to do anything to get the years to go to progress. What am I really interested in measuring here, the year or the alcohol usage? Alcohol use is the more important thing. That's my y variable here. So the alcohol usage is right here. Okay. So now you look at this and you see that's the scatter plot. Do you feel like a linear model might fit well to this data set? Probably better than what we did with the Electoral College a minute ago. Now to answer, you got to create that. So analyze regression mx plus b. And now I see this is the line of best fit. So negative 1.12255. So if I look at this, line of best fit, negative 1.2255 plus 2284.67, which is what you see here. So this is your line of best fit. Okay. And let's just see, what else do I ask you about this particular data set? We'll do that. Okay, yeah. So this is a model that I'm using to tell me about sophomores that reported drinking alcohol in the last 30 days, okay? Now, what could I use this model? What would I would create this line and create a model. What would I use it for? Once I have a model, I've got a formula for the model that models sophomores drinking. What would I use that for? If this tells you that, you know, this is a model for how many sophomores percentage-wise have reported drinking alcohol based on the year. You know, once I create the model, what would I use a model for? What do you do with models? You try to extrapolate or something. Right? So the last year I had data was what? 2016, or was it 16 or 15? 2016. So if I've got a model that tells me what's happening with sophomores drinking, what would I ask that model to tell me? Some kind of prediction, okay? So what does it predict that will be happening in the year 2020? So how will I use this to figure out what 2020 is going to give me? I will plug in that for the year, okay? So what I'm going to do is just come back over here and say y is equal to negative 1.12255 times 2020 plus 2284.67, okay? So we'll just do this on my calculator. So So negative 1.2255 times 2020 equal this number right here. So plus 2284. And I get, is that right? So 2020 times 1.12255 equal, put a negative on that, plus 2284.67. What are you getting? 17.19, okay? So what does that tell me? I estimate what? Pardon me? Anybody else 17.19? Oh, 119, you're right. 17.119. So this tells me we estimate about 17.119% drinkers in 2020. Okay. Now, let's look at this model. Can I use this model to figure out what's going to be happening 30 years from now? Why do you think that's a bad idea? Who knows? These are going to be your children. Who knows what they're going to be into? You know, I mean, I can't answer to that with this model. No, that's just, this model shows data over what period? Like 15 years? So can I take a model that's got data for 15 years and project it out for another 15 or 30? That's tough, okay? You know, if you were talking about world population over millions of years, maybe, but this kind of data, you know, it's sort of tough. Now, let's ask other questions about this. Suppose this information came from a survey. Suppose I passed around a sheet of paper and asked you, did you drink alcohol in the last 30 days? And I want to pass this around, everybody fills it out, and then I'm going to come back around here and take it up. What kind of data do you think I'm going to get from that? Good data? Huh? You think it's going to be very accurate? No, seriously. Why not? Well, it's a small group, but come on, be honest. Why do you think I'm not going to get data? Yeah, do you think sitting here at this school with the policies we have, if I say, guys, I'm going to ask you this question, have you had any alcohol in the last 30 days? And then we'll walk around, pick up your answers, and we're going to look at this survey. Do you think I'm going to get good data back? And I'm not trying to, yeah, I'm not picking on you guys, but okay, so that's sort of a tough thing. When you look at data like this, you have to ask yourself, under what conditions was the data taken? You know, it's not in your interest, you know, if you have done something in this survey, it's not in your interest to be forthclosing, you know, about that. So anyway, that's another part of the survey as well that you have to ask yourself when you look at things that have social implications. Okay, so there's the prediction here. But now the question is this a good data set to model with a linear model? Okay, that we have to figure. To do that, we have to figure out what? What will tell us that? Correlation coefficient. So calculator, menu, statistics, stat calculations, linear regression, mx plus b. My x variable was the year. My y variable was the alcohol. And what's the correlation coefficient here? R is what? Negative 0.979277. So negative. So right there, negative 0.979277. So correlation is a number between where and where? Negative 1 and 1. So this is a very strong negative correlation. So this is a strong negative correlation. By negative, as the years go up, the usage of alcohol goes where? Down. Okay. Positive correlation would be as the years go up, the usage of alcohol goes up. Okay. So this is a strong negative. So this value of R, strong negative correlation, it makes sense to model this with a line. Okay. Because you've got a very strong negative correlation here. Okay. Now let's talk for a minute when we have these two variable data sets. There's an independent and a dependent variable. The independent variable is going to be your horizontal or your x-axis. The dependent variable is your vertical axis. So the dependent variable is what I'm more interested in. So in this particular problem with years and alcohol, alcohol was what I was more concerned about. That's my vertical dependent variable. Suppose we're measuring the amount of carbon emissions by year. Which of those is the horizontal axis, the independent variable? The year would be the independent variable. That's something that's, I'm not doing anything to make the years go by, okay? And I'm not trying to measure years, but I'm trying to measure what? The CO2 emissions. So that's really the more interesting variable. That's my dependent variable. What if we're studying about nationality and how fast a person can run the 1,000 meters? Okay. Which of those, you got to ask, which of those is the more interesting thing that I can measure versus the thing that's just, I can't change or measure? Nationality, we can't change that, okay? You are a nationality. So that's my independent variable here, your nationality. What's the thing that can measure and can change, and I'm asking if it's going up or down? That's your race time, okay? So that's your 1,000 meter time. Most times you're going to find that time is your independent variable, like the years in the alcohol, the years in the electoral college. This is an example where the time was the dependent variable, okay? So I'm asking myself, like, can the Kenyans run faster than the Americans? So nationality is my independent variable. Time would be my dependent. Yes? Independent is only be on the x-axis. It's your horizontal, okay? And then the dependent variable, that's the thing your problem is trying to measure. That's what you're trying to report on. That's the thing that changes, the thing that's of more interest, okay? So let's look at another example here. Suppose I wanted to look at the size of people's feet versus their GPA. Which of those is independent variable? Yeah, because I really can't change your foot size, okay? But with studying, you probably have better chance of changing your GPA. So your feet, the size of your feet in this variable would be the independent variable, and the GPA would be your dependent variable here. So let's take a look at this. We've got a data set here that models that, and I'm going to, yep, I'll go ahead and I think I've got time to enter it. So let's enter this. I've got shoe size and GPA. So if I come over to my calculator, and part of the skill in this section is just getting used to your calculator, knowing what to do, list and spreadsheet. So I've got shoe size and GPA. So your shoe size, and let's enter that data, 8, 9, 10, 11, 10, 9, 7. So 8, 9, 10, 11, 10, 9, 7. GPA is 3.5, 4.0, 2.0, 2.9, 3.1, 3.3, 2.75. So I've got the data in. Where will I go next? What will I create? Data and statistics. What is my horizontal axis here? It's going to be the shoe size. What is my vertical axis here? GPA. Okay. Now, does that look pretty good with a linear model? I mean, that's one thing. Let's just show them a linear model. Analyze, regression, show mx plus b. Okay, so there is my linear model right here. So negative 0.108 something, is that right? Negative 0.108553x plus 4.0107105. Okay, so that's my linear model. So if I go back to what they're asking me here, I've got the data. How do I know if it's a good model or not? What do I have to find? Yeah, the R value. So that is found in a calculator page. So menu, statistics, stat calculations, linear regression mx plus b. I'm plotting shoe size versus GPA, and the R value is negative 0.231886. So in this case, So here was my line of best fit. And then if you look at R is equal to, what was it, negative 0.23.886. Is this a good data set to model linearly? No, that's pretty bad because I want it to be close to which numbers? 1 and negative 1. This is pretty far away. So this is, so the linear is not a good model here. So that's how I quantify it because the R value being so low. But when you look at this, you can tell that data really doesn't line up well to a linear model. Okay. Now we're going to have a couple examples here where I may give you a data set and then ask you some questions about the linear model that comes out of this. Okay. So in this case, I've got temperature and kilowatt usage of electricity. So I'm measuring. I think that in the summer, people use more electricity than in the winter, okay? Which of these is the independent variable? The temperature, because the temperature is happening. I'm not doing that. But can I control my consumption of energy in my house? Yes, that's what I'm controlling. So this is going to be the temperature, and this is going to be the kilowatt of electricity. So find a linear model that expresses the kilowatt usage of electricity in terms of the temperature. So that means this is my independent variable, this is my x-axis, this is my y-axis. So we'll put the data in, and then we'll go from there to find our linear model. So I will come back over to my calculator, and let's create a new list and spreadsheet. So I've got temperature and kilowatt hours. I'll just call that electricity. So when the temperature is, it looks like 57, 62, 69 and 71, 81 and 84. Those would all be nice temperatures for what we've been having lately. And the usage of electricity, 32.3, 34.2, 36.8, 39.6, 44.8, and 43. So determine the linear model, okay? So I got a couple ways of doing that. One way is doing it is what? There are two things we've done today. One thing I can do is to create a what? Come on, guys. How am I going to come up with a linear model? Yeah, so I can graph it. So that's one way. So I'm graphing the year versus the kilowatt. Okay. And that's the wrong year. Sorry. It's not year. It's what? Temperature. So temperature versus kilowatt usage. Okay. So it looks like a line would be good for this, but you can't just on a test say it looks good. So to figure out the equation of that line, I go analyze, regression, show linear. Okay. So that's how I come up with the equation of that line. It's 0.455643. So y equal 0.45563 x plus 6.25121. So that's the equation of the line that gives me the kilowatt usage based on the temperature, okay? Now that's one way to find it. The other way of finding it, how do I find the correlation coefficient? What do I do there? I create a what? Calculator page, menu, statistics, stat calculations, linear regression. So it's temperature on the x-axis and kilowatt hours on the y. So I didn't really need to come up with a graph because mx plus b, this is the number we just saw a minute ago, 0.455643, 6.25121. This is mx plus b. And what's the correlation coefficient? 97126. So 971026. Okay. What does this mean in terms of correlation? Is this what? This is what? Yeah, it's a very strong, what kind of correlation? Yeah, strong positive correlation. So it's very good to model this with a linear model. Okay. Then you've got to be prepared for the ability for me to ask you questions on this model. So what does the slope of this line represent in the context of this model? Okay, so first of all, you got to be able to look and say, what is the slope of that line? Yeah. So this is y equal mx plus b. So the slope of that line is what? It's what, 0.455. So it's 0.455643. But in the context of this problem, slope is what? The change in what? Change in y over change in x. What does my y variable represent here? In kilowatt hours. So this slope means that there's a 0.55643 increase in kilowatt hours for every increase in what variable? Temperature. Okay. So for every, and it's for every, I think, a degree, for every degree increase. So slope means change in y over change in x. What is y? Kilowatt hours. What is x? Degrees Fahrenheit. So this says I can expect a 0.455 change in kilowatt usage for every degree increase. So it's just putting this in context of the problem, okay? What does the y-intercept represent in this problem? So what's the y-intercept? What number is it? Yeah. You get the y-intercept when x is equal to what? No, you get the y-intercept when x is 0. Okay, you get the x-intercept when y is 0. So what would it mean? So the y-intercept is where I cross the axis when x is 0. What does it mean in this problem if x is 0? What is x? X is what in this problem? But I mean, in the value, what am I modeling? Toys, dogs, shoes, what? What is it? Temperature. So when the temperature is, yeah. So if the temperature is 0, then I find that I'm using what? 6.25121 kilowatt hours usage. So in this problem, the y-intercept means if x was 0, that means if your temperature was 0, that's the amount of energy you would be using. Okay, so you're basically just looking at this and putting it in context of the word problem. What does this model say would be my consumption when I reach 95 degrees? How would I figure that out? Plug it in for which variable? X, because X is the temperature. So this would be Y equal, and what is that formula? 0.455643. That's how I would figure out the usage at 95 degrees. I just plug this into the formula. So if I go back to my calculator page, 0.455, what is it, 643? 643 times 95 plus 6.25121 is what? 49.5373. So 49.5373. Please don't leave a number. This number means what? What does this number mean? It means the kilowatt hours used at 95 degrees. Now, the next question, what does the model predict the temperature would be to reach 35 kilowatt hours of usage? What are they asking me to do here? 35 for Y and solve for X. So this is 35 equal 0.455,643X plus 6.25121. Okay. And you got a couple of things you can do. How would I solve this for X? How do you solve this for X? Yeah, subtract. So this would be what? 35 minus 6.25121. All of that divided by what? 0.455643. That's going to be X. So if I do that, so it's 35 minus, so I'm going to have 35 minus 6.25121. Yep. 6.25121. All of that. Oh, it's 35. Yeah, thanks. 35 minus 6.25121. All of that gets divided by 0.455643. 455,643. That is what? 63.095. So that tells me that it's about 63.095 degrees to reach 35 kilowatt hours of usage. Okay. So these aren't as ugly of the word problems as we had on linear programming, but your answers can't just be 63, okay? It's in the context of the problem. I solved for what would be the temperature that I would reach 35 kilowatt hours, okay? Questions over this?